Good afternoon. This is a lecture on number systems. And the specific number systems we are going to talk about are decimal, binary, octal, hexadecimal, and that's it. So decimal. Decimal is the number system that you have learned since elementary school, or maybe even before then. Decimal has 10 digits in it, deci for 10, and those digits are digits 0 through 9. This is the number system that humans have come to know and love, mainly because we have 10 fingers on our hands, so we can easily associate with the number 10. Binary has only 2 digits. And what are those 2 digits? 0 and 1. This is the number system that computers speak. Why do computers speak binary? Because computers are made up of billions and trillions of transistors, and transistors can be on or off, 1 or 0. Now the octal system, oct for 8, has 8 numbers in it, and those digits are 0 through 7. Then we have the hexadecimal number system, which is 16 digits, and those numbers are 0 through 9, the first 10, and then we use the letters A through F to give us the rest of the 16. Now, octal and hexadecimal really become useful for us as electrical and computer engineers because they help us deal with the ones and zeros in binary to make it a little more human readable. So a little more terminology about number systems that you should know is this word called radix. And what is a radix? A radix is a number of digits in an ordered set of symbols in a number system. So your radix for the decimal number system is 10. For the binary number system is 2. Octal 8, hexadecimal 16, etc. So you also might want to look at parts of a number. You have a part, a dot, and another part. So this dot here is called the radix point, and on the left of it is the integral part, and on the right of it is the fractional part. You're all very familiar with this. So what does this mean? Well, let's start with the decimal number system, which we are all familiar with. I'm going to create a new page here and try out this pen. So let's look at what the different places around the radix point represent. So we've got a dot, maybe. And to the left of the dot, we have the 10, try this again, the 10 to the 0th place. Then we have the 10 to the first, the 10 to the second, the 10 to the third, etc., etc. To the right, we have 10 to the minus 1, 10 to the minus 2, 10 to the minus 3, etc., etc. So any number that you place in this spot will be multiplied by a 1. Any number you place in this spot will be multiplied by a 10, by 100, etc. And this will be 1/10th, 1/100th, 1/1000th, etc. Right? Excuse me. So we know the number 397.15 means there are 9 100ths, 3 10s, 7 1s, 1/10th, and 5 100ths. So this formula, as you might call it, is the same in any kind of number system except you change the radix and the number of digits that you use in the system. All right, so let's look at the binary number system. So binary is base 2, so we have our radix point. To the right of it, we're going to have, to the left, we have the 2 to the 0th place, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, etc. And to the right, we have 2 to the minus 1, 2 to the minus 2, 2 to the minus 3, etc. So this place will represent a 1, this will represent a 2, a 4, an 8, a 16, etc. On this side, we'll get a half, a fourth, an eighth, etc. All right, so now we only have 2 digits to choose from. So a binary digit can be a 0 or a 1, and we get the term bit, which stands for binary digit. All right, so we can use bits to represent a number. So let's say we had the number 10, I'm writing it backwards. Let's say this is our number. 110101.11. Now, this would mean something to a computer, but does this really mean anything to you as a human? No. So, what we can do is convert it into decimal. And how can we do that? Well, we can just see what are these numbers weighted. So just like in our base 10 system, we could multiply by the ones place, the twos place, the threes place, etc. Or sorry, the ones place, the tens place, the hundreds place, etc. Here we multiply the ones place, the twos place, the fours place, the eights place, etc. So this number has the ones place, the twos place, the fours place, the eights, the 16, and the 32. So this number is going to say, okay, we're going to have 32 plus 16, no eights, plus 4, no 2's, plus 1, plus a half, plus a fourth. So what number are we going to get here? Well, we're going to get 32 plus 16 plus 4 plus 1. What is that? That's 21 plus 32, which is 53. Half and a quarter is 0.5 plus 0.25, so 0.75. So this number, 1101.01.11, is the same as 53.75. Now we can explicitly state that this is in Radix 2 and this is in Radix 10. So did everybody see how we got that number? Okay, so let's try going the other way around. I'm going to create a new page. Let's go from 87, I think it's better to write down here, 87 base 10 into binary. So how do we figure that out? Well, what I like to do is just write up what all my place values are. So I had the ones place, the twos place, the fours, the eights, the 16, 32, 64, 128. These are all powers of 2. Dot, blah, blah, blah. We don't have a fractional part in this number, so that doesn't really matter. So with 87, I first select the largest power of 2 that fits into 87, which is 64. So I put a 1 there. I don't have any of these. Now, if I take 64 away from 87, I'm going to get 23. So I don't have any 32s, but I do have a 16. So now if I have 64, not good writing up there, 64 and 16, this is going to give me an 80. I have 7 left to go, so I don't need an 8. And I do need a 4, I do need a 2, and I do need a 1. So if I add these all up, 64 plus 16 plus 4 plus 2 plus 1, I'm going to get 87. So 87 base 10 is equal to 1010111 in binary. Now there are other ways of doing these conversions, but this is what I find to be the easiest. Now, as an electrical and computer engineer, or computer engineer, you want to memorize powers of 2. So I'm going to write those down on the next page. We have 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6. This is 1, 2, 4, 8, 16, 32, 64. Let's do some more. 2 to the 7, 2 to the 8, 2 to the 9, 2 to the 10. You can keep going. So after 64 is 128, 256, 512, 1024, 2048. Let's do to the 2 to the 12, 4096. I think that's all I have memorized up to. So yeah, spend some time and memorize these powers of 2. It will come in major handy-dandiness. Okay, so what about this octal and hexadecimal number system? Let me start a new video to explain that.